Hey guys, welcome back to day 36. We're talking about oxidation and reduction today. And let's dive right in with saying that there are two principal types of chemical reactions. What are they? Well, the first one is acid-base reactions, which we covered in the previous video. And we're going to talk about oxidation numbers. Do not change. We look at it through the lens of H plus or proton transfer. And that becomes more apparent in Chem 2. But acid-base reactions, we do not have oxidation numbers change. So how we're going to define oxidation numbers, they're not going to change in acid-base reactions. And the other class of reactions are redox reactions. And here, oxidation numbers do change. The next obvious question to me would be, what's an oxidation number? Right? It's a way to keep an account of electrons in a chemical reaction. Now, this is a good system to do so, but that doesn't necessarily mean that's what the atoms are doing. This is how this is a system humans use to predict behavior for reactions. That's a good way. So let's do an example here. Sodium metal. If I throw sodium metal into water, the net ion equation, I get 2 sodium ion plus 2 hydroxides plus hydrogen gas. Oh, not H2O, H2 gas. Okay. Well, let's look at sodium first. And if we look at the periodic table, we can look at the atomic number, which is the number of protons. So the atomic number of sodium is 11. So 11 protons. However, sodium metal doesn't have a number for electrons. It has, how many electrons does it have? Well, if it's neutral, like this one, it will have 11 electrons. On the other side of the arrow, though, we're positive. So that means we lost a negative particle. I have one more positive than negative. So that means I would have 10 electrons. That's a loss of 1 electron right here, isn't it? We lost 1 electron. We're going to call that oxidation. Oxidation would be the loss of an electron. Now, we know, there's the arrow, that the law of conservation of mass applies. So on the left-hand side of that arrow, the same number of protons, neutrons, and electrons as there are on the right-hand side of the arrow. So where did the electron go? Well, this is not as obvious. And this is where we're going to get to these rules. So first, the oxidation state of hydrogen gas is 0. Right? Why? Because each hydrogen has 1 proton and 1 electron. But it's not so obvious that here hydrogen is plus 1. And so our gain of electron happens here. And we're going to call that a reduction. Because the charge is reduced from plus 1 to 0. So it was pretty obvious with sodium. Yeah, I got it. It's got 11 protons, 11 electrons. It goes to sodium ion. It's 11 protons, 10 electrons. I get that it lost an electron. Okay, fair. What about water going to H2? How is that a gain? Well, let's talk about our oxidation number rules. We have rules for this. The first rule is that an element by itself equals 0. So that would be like F2, O2, Na, Cl2, S8, etc. All those, they have the same number of protons as they do electrons. 2. I got space here. 2. A monatomic ion equals the charge of the ion. So that's F minus, O2 minus, Fe3 plus, etc. So F minus would be minus 1, O2 minus would be minus 2, Fe3 plus would be plus 3. Those are our oxidation states. So an element by itself has the same number of protons and electrons, 0. Monatomic ion, same, the different number of protons and electrons, we can find the difference, get the charge. So the charge is the oxidation state. For 3, fluorine is -1 in compounds. Fluorine is -1 in compounds. So when's fluorine not -1? When it's an element by itself. Otherwise, fluorine is -1 in compounds. Period. 4, oxygen is -2 in compounds. Except, right, with fluorine, it doesn't look like fluorine to me. Let's fix that. There we go. OF2 with fluorine, peroxides, and superoxides. So fluorine with oxygen, oxygen is going to be +2. For superoxide, it's going to be -1/2, and for peroxide, it's going to be -1. And what do you mean by -1/2? It's a great question. Let's look at that. So O, O, and it's minus. So I have how many electrons? 13 electrons. 2, 4, 6, 8, 10, 12, 13. Therefore, one oxygen, 2, 4, 6. The other oxygen, 2, 4, 6, 7. One of the oxygens is -1, the one's 0. It's a radical. The radical's in resonance. So on average, it's 1/2. So we take the average. So technically, one of them is -1, one of them is 0. That's how that works. But we just call it -1/2 and go with it. Number 5. Staying with the negatives. Chlorine, bromine, iodine are -1 in compounds, except when paired with fluorine or oxygen, such as ClO3-. That would be an example where chlorine is paired with oxygen. So their chlorine is, what's that, +5. There are times though when chlorine, if there's other elements that are there, even H doesn't count. H is going to be +1. We're going to talk about that right now. So if there's other elements like carbon or something else, then it changes. It's kind of like a pecking order. So number 6, hydrogen. Is always, and there's always +1 in compounds with non-metals. However, it can be -1 when paired with a metal, such as NaH, sodium hydride. There, Na is +1, H is -1. And last but not least, number 7. Group 1 is +1, and group 2 is +2 in compounds, always. Always. So groups 1 +1, group 2 is +2. There is no change to that. So those are our 7 common rules. Now, what if I have something that's not in these common rules? Okay, I don't have. So we're going to start it off. When we do the rules, we'll start off. Is it an element by itself? Is it a monatomic ion? Is there fluorine, oxygen, Cl-Bri? Is there, so the rest of the halogens? Is there hydrogen? Is there a group 1 or group 2 metal? And there might be no to all those answers. What do we do? Well, here's the note. The oxidation number on an element in a molecule is the charge the atom would have if the electron in the bond were assigned to the more electronegative atom. So the more electronegative atom gets the negative charge. Let's do some examples now. There we go. Now, when we do examples, I didn't say this. If I have X, Y, and Z, the oxidation numbers I'm going to put up here are my oxidation numbers. This is going to be my oxidation numbers. Down here in blue, I almost always use blue in class. This is my math help, and it always equals the charge. So my math help will always equal the charge. So the oxidation numbers always add up to the charge. Now, but they don't not add up to the charge because I might have a -2, a +3, and a -2. But because they're subscripts or whatnot, the red numbers you get through some mental math. The black will just be, or the blue will just be straight across. So let's put this to practice. Magnesium phosphide. The oxidation numbers down here will add up to 0. Now, this is a binary ionic compound. Binary ionic compound, the charges are the oxidation states, and you probably already know what they are. But let's go through the list. Is it an element by itself? No. Is it a monatomic ion? No. Fluorine? No. Oxygen? No. Halogen? No. Hydrogen? No. Group 1 metal? No. Group 2 metal? Yes. That group 2 metal is magnesium, and magnesium is going to be +2. And there are 3 magnesiums, so that means it's a +6 here underneath magnesium for my math help. Well, what number has to go here? +6 minus what equals 0? Well, it has to be a -6. And since there's 2 phosphoruses at -6, each phosphorus is -3 for phosphide. And we knew that, right? We know phosphorus is -3, magnesium is +2. This is something we should know from the naming and making the ionic compounds, naming the binary ionic compounds. We know it was magnesium +2 and phosphorus is -3, and the anions don't change. We're just putting it into a different perspective with the oxidation states. It's the charges and the oxidation states for this binary ionic compound are the same. We're just looking at it a slightly different way to get to the same result. Now let's jump over to permanganate here. Now for my math help for permanganate, I add up to -1. Well, let's look at this. Is it an element by itself? No. Monatomic ion? No, it's a polyatomic ion. Okay. Fluorine? No. Oxygen? Yes. It has oxygen. Oxygen is what state? It's -2. There are 4 oxygens, so that's a -8. Which means manganese then has to be what mathematically to make X here? -8 equals -1. So that would have to be a +7, wouldn't it? +7 minus 8, -1. So manganese is +7. So now my answers are up here in red. These are my answers. These are my oxidation states. That's what we care about for behavior purposes. Down in blue is my math help. That just helps me do the math. Because obviously 7 minus 2 does not equal -1. But 7 minus 8 doesn't equal -1. So that's why we're doing what we're doing. Okay. ClO2 minus. Chlorite. Chlorite, the oxidation numbers add up to -1. Okay. Is it a monatomic element by itself? No. Monatomic ion? No. Fluorine? No. Oxygen? Yes. Oxygen is -2. And there are 2 oxygens. So that's a -4. So what does chlorine have to be? Well, X minus 4 is -1. Looks like it has to be 3. 3 minus 4 would be -1. So chlorine has to be +3. Bromine trifluoride. No charge, so we add up to 0. Element by itself? No. Monatomic ion? No. Fluorine? Fluorine is there. Fluorine will be -1. It's in a compound. Fluorine is -1 always. So we have -3. Well, what has to be underneath bromine? It has to be +3, doesn't it? But wait a second. I thought bromine, chlorine, iodine were -1. They are, unless they're paired with F or O. This is a pairing with F. Fluorine's going to take its electrons first, then bromine gets to come to the table. It's kind of like if you're eating steak. Imagine you're in the backyard eating steak, right? Well, if you're a pretty big person, you get to eat before other people, unless you're nice. But if all of a sudden a lion came up, I think you would be very happy to give your steak to the lion. I know I would, right? Because the lion, unless you have weapons on you, the lion will win. So we just give the steak to the lion, go inside, be done, right? And so it's a pecking order. Kind of like the lion eats first, then the scavengers, then the vultures, right? Same thing here with the electrons. Fluorine's going to go first, then oxygen, then the halogens. So since fluorine gets to go first, it's going to be -1, and then Bromine gets the leftovers. In this case, there's none. Sulfate. Sulfate is -2. Adds up to -2. Math help. Okay. So, fluorine. Well, it's not an element by itself. It's not monatomic, not fluorine. It has oxygen. Oxygen's -2. There are 4 oxygens. So that's a -8. What has to be underneath sulfur? It has to be +6, doesn't it? It has to be +6. Calcium hydride. Math help. Adds up to 0. Is it an element by itself? No. Monatomic ion? No. Fluorine? No. No oxygen? No halogen. Has hydrogen. Hydrogen's +1 with nonmetals. Calcium's a metal. And if we don't know that, just make sure you have your periodic table out. Always, just a little reminder, always have your periodic table out when you're doing chemistry. Will you use it every time? No. But it's a good reference to have. It's a reference. Always have it out. So you can look, calcium's a group 2 metal. And if we skip down, calcium is going to be +2 in compound. Always. It's just like the rules at my house. Mom's always right. Rule number 1 is mom's always right. Rule number 2, if mom's wrong, see rule number 1. That's how it is at my house for my kids. Here, calcium's +2 in compounds. Well, wait, I don't think it is. Guess what? Calcium's +2 in compounds. So something else has to change. So if calcium's +2, that means I have to have a -2 in front of hydrogen, which means each hydrogen is -1, which it can be when it's paired with a metal. So it works out great. XeOF4. Math help down here. Adds up to 0. So who do I start with? Well, it's not an element by itself. It's not a monatomic ion. I have fluorine. Fluorine's -1. And there are 4 of them. Then I have oxygen. Is oxygen paired with fluorine, or is there more than 2 elements there? There's more than 2 elements, and one of them is not hydrogen. So oxygen is going to be -2 as well. And that's a -2. That means the xenon is going to be plus what? Looks like it's +6, isn't it? And there we go. That's oxidation and reduction, oxidation numbers. And so in the next video, we'll do examples and pull it together. Take care.